So, nice to meet you all. I'm Samuele. I'm the mobile tech lead at Empatica, and here on stage with me there is Pietro. It's my colleague and lead US engineer. And also Alessia is the lead embedded engineer that unfortunately she couldn't attend today. She didn't feel well, so yeah. Okay, so today we will talk about Bluetooth. We will talk about some challenges we experienced developing a Swift library to communicate with wearable. From the design of the architecture, testing the Bluetooth without the wearable, keeping your app running in background 24 hours, and finally also a showcase what we built for the production line. Let me first super briefly introduce Empathica. We built medical devices. The devices are used to collect raw biological data and create algorithms for monitor the health. We are about 80 people, international, and 52% are female. It's female. So now that you know what we do, we would like to tell you a story. Back to January 2020. Empatica started to build a new ecosystem, or a new wearable, a new SDK, and a companion app for the wearable. And the communication was based on Bluetooth 5. At the beginning, the hardware was not so fancy. Imagine the software. Everything starts from a prototype like this. A lot of wires, and we had just one single prototype in the office, and we shared between firmware and developers and mobile developers. We were sitting side by side with the debugger. We also developed a Swift UI app, tester app, that used to collect data, validate the prototype, and start building the libraries. It was such a beautiful moment in the office. But we know what happened. As you imagine, everything became crazy. Everyone at home, baking pizza, working remotely. Everyone on Zoom. We even put a desk in the bathroom. In this situation, we faced many challenges because the development was not so easy as before. Remote working pushed us to focus on the stability of our code. Without the device at hand, we had just one prototype. Of course, the firmware developer has priority, so mobile developers needed to adapt. We want to share our experience with Bluetooth. Let's start introducing quickly some basics about Bluetooth. I will not go deeper in this, but just quickly. To interact with Bluetooth, such as wearable, we need to use CoreBluetooth framework from Apple, and you can find two main classes, the CB Central Manager and the CB Peripheral. CB Central Manager is the handler class for all the communication, and the CB Peripheral is the model to represent the remote device. We need these classes to connect and send or receive packets from our wearable. The Bluetooth Low Energy organizes the information using services and characteristics are like endpoints from the cloud. Just to make a metaphor. Imagine characteristics as a variable, and you can assign and read a value of it. And you use the CB peripheral implements this organization. Instead, the central manager allows to do all the operations, like scan the Bluetooth devices nearby, perform the connection, and read and write values. But please, to go deeper, please refer to Apple. There's a lot of documentation there. So, first element, of a good software and a good app is a testable architecture. In order to connect a device, we said we need a central manager that actually, under the low layer, creates a channel with the system. So it's namely an XPC connection. It's possible to create a single central manager and handles all the connection with even multiple devices. So you have but in your code you need actually to switch and understand which device is communicating. Okay, imagine a switch on your peripheral identifier. But if you want to connect to multiple devices, a possible approach is to have multiple central manager, one for each device. This way, we have multiple connection with the system, so multiple channels. This is not for free because, yeah, it has a little of overhead in terms of system resources, but is actually, with the testability concept, it's better because it's isolate and decouple each peripheral. So if you are debugging or you have issues, one peripheral doesn't interfere with other peripheral. The central manager need a serial dispatch queue. Serial because, yeah, all the messages need to be in a queue to execute the callbacks from Bluetooth. And it's better to have a good. It's good to separate queues for each peripheral. Otherwise, one communication while sending packets can slow down the other peripheral. Usually, we need to put a string to identify the label, but to have multiple queues, one for each peripheral, yeah, just put the peripheral identifier as part of the label. So while debugging, if you stop the debugger, you can see which peripheral has an issue or not. And then, yeah, pass the queue to the init function. Last, about scanning. We also created a separate central manager for the scan of the peripherals. It's basically separate the scan callbacks and, yeah, isolate also this. And yeah, you can create basically a separated component from the connection. You can notice a lazy variable because to allocate the central manager, it's important to allocate it at the right time because it will trigger immediately the permission pop-up. So yeah, it cannot appear maybe just after the splash screen. Okay, a good software architecture was the basis, but not enough. We need real testing. So, without the prototype, what we did? As said before, yeah, one prototype, and we need to simulate basically our peripheral. We were at home, so we need to invent something. With CoreBluetooth, it's pretty easy to create a virtual peripheral and create a macOS app. We created a macOS app. You can do it even for iOS, to simulate the device firmware. Actually, we implemented the same firmware even in Swift. We connected, of course, iOS and Android app to the Mac. To create go through to how to create a peripheral. A few steps. First, you need an instance of CB Peripheral Manager. This is another class from CoreBluetooth. You need to conform to this Peripheral Manager delegate and receive all the callbacks. There are many. To know when the peripheral manager is ready, and then start advertising with your nice name and so on. As a virtual peripheral, for example, you can send periodically data. Every 60 seconds you send something, and then basically you simulate states, and the app will react. But should we be aware about macOS stability because it's not the best? Yeah, we needed to kill the Bluetooth process a lot of time and switch on and off and reboot and so on. You can find a complete sample code on our GitHub about this. Yeah. A virtual device was amazing, but again, not enough. We can use a virtual device on CI. We use Bitrise. So let's talk about testing. We keep talking about testing. Unit test the Bluetooth, and making the test repeatable and even automated. A real wearable is not possible to incorporate in the unit test, also because become an integration test. We need to replace the CB peripheral with something else, a mock peripheral. Okay, but to replace the peripheral, what we can do? We can maybe inherit from the CB peripheral. Fantastic. Oh no. The init function from the CB peripheral is not available. You cannot do it. How to solve this? with protocols. We can do protocol-oriented programming, and we can define our protocol, our Bluetooth peripheral, generic, abstract, and conforming the CB peripheral class to our protocol. And of course, using our protocol, our abstraction in the code, not the CB peripheral. Simple, yeah. Then, actually, we need to copy and paste all the variables and functions from the original CB peripheral definition. You can go in Xcode, show interface, and you can copy and paste, adjust a bit, and that's it. So, yeah. Then, yeah, finally, we have the Bluetooth peripheral protocol. We can create a mock, a peripheral mock I wrote. Yeah. You can put a fake state. You have the init, fantastic. Now you can implement all the function and return stub data and so on, and you can simulate any kind of behavior. You can even have multiple mock. The same approach applies to all the system classes. Yeah. To conclude the testing part, yeah, running around the room is the way to testing connection stability. I remember going to the chicken and put our wearable in the fridge to isolate. Yeah, but it's not so, it's time consuming and so not so nice. So we built a machine to move the device in and out in a metal tube to force a disconnection. So just, yeah, our QA was amazing. Okay. Okay, testing, yeah, was very, very important in the 2020. App that, in general, that works with Bluetooth may need to stay alive in background for hours. Our app runs all day. This is not easy with iOS because, yeah, it applies a lot of constraint, but we have some tricks. So first, yeah, just basics. Some basics. To run the app in background, we need to enable background capability in Xcode. Yeah, just flagging uses Bluetooth LE accessories and background processing, just a couple of flags. Then, about Bluetooth, we need to implement the state restoration of the central manager. It's a feature, basically, that inform the system that you want to be, that your app won't need to be relaunched if a BLE event comes in. Sorry. So, due to this, we need to inject as an option the restoration identifier, and in this case, yeah, we use the identifier of the peripheral, and we need to implement the delegate will restore state. And yeah, just a good practice, but maybe, I don't know, it's our practice. It's to keep a strong reference to the peripheral until you actually restore a connection to avoid the leaks. And yeah, that's it. When you're sorry. When the app runs in background, yeah, the system can decide to terminate your app anytime. So yeah, because yeah, the system need to save battery. But if you are connected to a Bluetooth device, yeah, you are a bit special. So if you receive a BLE event, the app will be relaunched. So then every BLE packet extend the background time of 10 seconds. So the system gives you a grant. But pay attention, do not fight against iOS. So they still work with it. So make peace. Measure your code performance, and with the instruments, with all the tools, to execute everything in few seconds. So it's very important to be to write beautiful code. So otherwise, and let the system suspend the app again. So be relaxed. In our case, our wearable emits a packet every 60 seconds. So basically, every 60 seconds, every minute, the system wakes up. We receive a packet. The system wakes up our app. We check for data, and we process it, and then that's it. And the app gets suspended again, and so on and so on. Okay, finally, yeah, it's not enough, all these tricks, and the user need to be educated. If you want an app that is always on, if the user swipe up the app, it's done. Game over. So the user has to be educated a bit, and yeah, we introduced some UI elements, custom view shown just in the app switcher, and a local notification after the termination. So on application did terminate, yeah, you schedule a local notification. Finally, from iOS 15, Apple give us a gift. So it's basically a new option in the developer settings, in the general settings. But basically, it simulates the fast app termination, and yeah, you just need to turn it on. And when putting the app in background from ground, basically is terminated immediately. So if after some seconds you receive a new BLE packet, the app should be relaunched. Yeah. So to conclude, yeah, that's all about testing about Bluetooth in Swift. Now Pietro will show you something we built for the production line. Welcome, Pietro.
Thank you, Samuel. I mean, once we developed the SDK and also the hardware, I mean, the challenges were not over. In fact, we started the mass production of the devices, and we had to implement an automatic process to test the hardware. In fact, the same way we test software, the hardware as well need to pass some tests to be defined production ready. And unfortunately for the hardware, the situation is a bit more complicated. I will show you briefly how hardware test works. I mean, usually an hardware test session is composed by a controller that is a normal computer, then an actuator that interacts with, is a bot that interacts with the device, and then of course we have the device that we wanna test. Here you can see a very simple test that we run in our end of line. As you can see, the controller starts testing, asking the actuator to push a button, the actuator pushes the button, then the computer asks EmbracePlus what is the button status at the moment. Then when he receives the data back from the EmbracePlus, he makes his valuation and return the test result. So as you can see here, there are a lot of technicalities involved. Me and Samu, as part of the mobile team, we focused on the finding a way to allow communication between computers and EmbracePlus. Yeah, in the past we had a similar issue, a similar challenge actually, developing the previous device, and the solution that we produced was a custom software written in C#, developed by hardware engineers, and the communication between the software and the device was granted by a Bluetooth pen drive. I mean, the results were not so good, so this time we decided to do it differently, and Swift gave us the right tools. Indeed, we realized that the SDK that we just developed for iOS was, I mean, could run easily also for macOS. And when I say easily, I mean very, very easily. I mean, this is all the work we had to do, so adding a line of code in the package.swift file. So we ended up developing a macOS app composed by two components, the HTTP server that communicates with the controllers, listening for requests, and then the SDK that instead allow the communication with the EmbracePlus. I mean, this solution was much better compared to the previous one, especially because we did re-implement the entire interface communication, but we use our SDK. Then, since we develop a macOS app, we can now rely on the Mac App Store to update the code, and this is reduce a lot the effort required by the operators in the production plant. So, I mean, the final result was much better. Our tip here is, I mean, do not forget that iOS is just part of a much bigger and much powerful ecosystem. And Swift is the foundation of this ecosystem, so you can use most of the frameworks provided by Apple, also macOS, but also watchOS, you have tvOS. And by the way, Swift works also on Linux. I mean, you cannot use CoreBluetooth on Linux because it is an Apple framework, but there are few alternatives, and these are just some examples, but again, Linux is also an option. So now we would like to conclude the presentation with a few last recommendations. First of all, if you wanna get more debug information, especially during the development, you can use the Bluetooth profile provided by Apple. You can download the profile there, then you have just to install it into the device, and then download an additional tools in Xcode, and finally, here you can get much more logs. As you can see, they are very low-level logs, so you can really understand what is happening between your app and the Bluetooth device that you are testing. Finally, few Apple resources that we found very useful during these 2 years of development, because I mean, of course, the first reference should be the official Apple documentation, but sometimes it's not exhaustive and not always updated. So we booked several one-on-one meetings with Apple engineers during the last 2 Apple conferences, and we found it very, very useful. So if you didn't in the past, we recommend to do that on the next conference if will be available. And then finally, we also use the feedback assistant for developers. I mean, here the time could be a bit longer. I mean, it took more than 1 month to have the right answer from Apple engineers. But this is also a resource that Apple provide to you to deeper into issue or problems that you could face during the development. That's all. We really thank you, and if you have questions,